All right. Hello, everybody. Welcome to today's talk about implementing policy as code through Open Policy Agent. My name is Marudamaran Gunashekaran. I work as a principal consultant at Practical DevSecOps, a HISMA company. And here's a little bit of slide about me. I used to be doing development, IT, work with a lot of IT folks. I've been an agile coach, worked with compliance, and for the past 5 years, actively digging through anything under the sun that is called DevSecOps. Well, there's some courses that I've authored at Pluralsight. I'm passionate about teaching and training people besides consulting. And one of the things that I'm also proud of is creating the OWASP ZAP .NET API project. And there's plenty of other certifications that I've gained as well from security, agile consulting, and so on. I'm a kind of person that wants to see things first before I get into anything theoretical. So what I'd like to do today is start with a demonstration first about policy as code through Open Policy Agent. Now, when I had to learn this technology, policy as code through Open Policy Agent, I scoured the internet through plenty of conference videos, and there's great talks about how to implement policy as code and APIs and Kubernetes and other things and whatnot, but I couldn't really find that information about the essential nuts and bolts that are required to actually implement policy as code in your own application. So this is my learning experience during the work that I did on Open Policy Agent, and that's something that I'm glad to share with you guys today. So we have a front-end application that is built in Python Flask. It's a car management application, a really simple application that facilitates its identity through Azure as an identity provider. And what happens is this front end also has this backend, which is basically APIs. And these backend APIs is where we're going to discuss policy as code today. And notice that the backend APIs are actually live together with policy as code. So policy as code, as its deployment principle, considers itself to be as a part of the backend APIs itself. Now, we're going to see this demonstration as a backend API. And the reason for that is if you know HTTP, anything basics about the web applications, APIs, and HTTP, then that's all is required for you to understand the purpose and the existence of policy as code through Open Policy Agent. And when we understand the very basics, then we can switch gears and go to other advanced topics such as Kubernetes, Istio, service mesh, and whatnot. So that's the demonstration. What I'm going to do is quickly jump back to my browser. This is our practical DevSecOps labs, and I've already gone ahead and set up all of these web applications. The only thing that I'm left to run is to run the Open Policy Agent with a policy called API odc.rego on HTTP port 8000. So when I hit enter, Open Policy Agent runs fine. And this is the sample front-end car management application. When I hit sign in, I'm going to be taken to Azure AD. And there's two major type of users in this application. Misbah is a regular user with a role called everyone. They're just everyone, any user that has account on their system. And Imran is a privileged user with car administrator privileges. Now, Imran is able to add cars into the system, but because Misbah is a regular user, she's not able to add cars into the system. She can just view the list of cars and perform a few other operations. When I hit sign in, I'm going to be taken back to the application with an authentication token that consists of an access token for authorization and an ID token for authentication coming directly from Azure AD. Now, what Ms. Bastian can do, she can get cars. So let's see if she's able to get cars. Well, she's able to get cars. When I hit that invoke button, we fired a call to the backend APIs, and the backend APIs checked with Open Policy Agent to see whether Misbah can actually get cars or not. Now, she's able to get cars. Is she able to put cars? Let's verify that. And the sample data to add cars looks similar to this with a car ID. Now, if I perform this operation, since Misbah is a regular user, she will not be able to get cars. Sorry about typo there. That's the right URL, put cars. So Misbah gets a 403 forbidden error message because she's not a car administrator and she's not able to put cars. Now, imagine this is your organization's policy, and the application, car management application, was sort of in a beta phase till now, and now the application decided to go public. The organization decided to allow every user that has an account on the system to be able to put cars. Now, if you think of that as a policy change, typically that is managed through a compliance team or a policy team, written in documents, goes through JIRA tickets, and then somebody writes that policy, puts it as a part of a product backlog item, and a developer implements it in multiple places. Here, our application is running in Python, but what I want to demonstrate here is if you have policy as code, I'm going to quit this open policy agent here. I'm not doing anything else. The application is still running fine. Quit open policy agent and explore the policy file that is named API API.rego. Now, Rego is a declarative policy language that works together with open policy agents. So that's something that we need to learn if you want to learn policy as code with open policy agent. But I got some tips for you toward the end of the presentation to ease the barriers of entry for you to pick up open policy agent and OPA really quickly. So if we kind of look at what's inside the policy file, API.c, there's a lot of these files. There's a lot of code in these files. Now, this file started with one single line. I took an example from the Rego playground, which we will look at towards the end of the presentation. And then I started building and writing this policy. If I clear this screen and try editing this policy with Nano, remember the policy that I want to change right now is to make everyone able to put cars in the organization. So if I go all the way down until the point where the documentation says, okay, so this is the policy rule that allows everybody to get cars. What I'm going to do is add another rule to this policy called allow when input. I got to type carefully not to make any typos there. Otherwise, we'd have to spend time troubleshooting this. Input method is equal to put. Remember, when Misbah tried to add cars in the system, she tried to use the put method with a certain API path. So when the input method is put, and if the path of the API in the URL is, let me actually borrow this from bottom right here. If the path of the APIs is cars, comma car ID, and as long as the user is authenticated, which we can decide in this policy file by just putting in the user variable in there, as long as there's an authenticated user and the input method is put and the path is cars.id, then that operation should be allowed for everybody. And with that, what I'm going to do is save that file, exit out of Nano, and then run the open policy agent on its HTTP API, just like we did before. And hopefully everything works fine, okay? No errors on the policy that we edited, so OPA runs fine. If I go back to the application, when I hit invoke again, I'm expecting this call to succeed. And as such, it succeeded. And the key point to take away from all of this is you've had a Python application and a Python API built on all different kinds of technologies, but when an organization policy on the authorization of that application changed, you only had to change the policy that was responsible for changing that, the policy that was responsible for making that authorization decision. So that was the only thing that needed change, and everything else remained the same. The application code did not need it to be changed, and the API code did not need to be changed. The only thing that needed change is the policy file that was responsible for making authorization decisions in this case. With that, A little bit of demonstration. I'm going to switch back to Keynote, go on Power. So there we are. So that's the demonstration that we did. The agenda for today is to look at that demonstration, and hopefully that should tell you why you should consider policy as code. And a little bit of tips in terms of if you are trying to integrate any app with policy as code to an open policy agent, how can you do that? And I'm going to demonstrate that by showing how this Python app and API are plugged together with the policy decision engine. And then finally, if you have to write regular policies, what it takes to write regular policies and a lot of resources to get you started. First things first, traditionally policies are written as documents like we discussed before. Somebody writes them, either operations or information security. Sometimes even the CISO office writes these policies, and then they version those policies, they put it up for the consumption of the entire organization. And then those policies are translated to the engineering teams, operations teams, and that's how policies were traditionally managed. Now, when infrastructure is moving as code, when compliance is moving as code, why not policies move as code? Now, on the left, what you see is a policy as an example. By default, there's an allow is equal to false. This is a firewall rule where we start building security by not allowing everything, and then whitelisting things by allowing what we trust. There's a policy over there on your right, on your left, that says by default, everything is false. And then there's a set of rules in this policy that says, if the method is allowed, and if there's cars with car ID on a path, and if there is a manager, then that policy needs to be allowed. And with this kind of policies written as code, there's advantages that you don't have to duplicate your documentation somewhere. And of course, organizations for compliancy reasons might level some level of documentation, but wherever we need to document role-based access control or anything else that comes as a policy, and that can be documented. And there's also advantages of automation when you're writing these policies. You can unit test these policies repeatedly, very fastly in your CI/CD systems, and then also make sure that they're versioned. And then whenever a policy is changed, you can also run coverage on those policies to see whether your policy during runtime will actually get executed through all the lines of the policy, or only few rules of your policy would get evaluated or not. So those are some advantages of moving your policies in a code fashion. Here's a quote from Torrance Sendel, who's a co-creator of the Open Policy Agent project, that said, we have evolved, our software development procedures have evolved to treat systems like database as a separate entity, messaging as a separate entity, monitoring, logging, orchestration. These are separate entities these days. So now it's time that in that path of evolution, we treated policies as a separate concern as well. And that's a great quote to take away. Learn policy as code because there's a lot of great advantages. Here's again a screen grab from the Open Policy Agent website itself that says this is a fine-grained, flexible, declarative language to manage policies across your entire enterprise or cloud-native stack. Focus on that picture. There's ingress coming in the form of a big ship, battleship, dragon-faced battleship, and there's Kubernetes as a fort. And then inside your organization, there's various different things. There's data, SSH, user interfaces, APIs, web applications, and whatnot. Now, OPA as a single policy decision engine, because it is very generic, because it is fine-grained, because it is declarative, it can work with any given system in your organization with very little prerequisites, which we'll go through in the upcoming slides. But for now, one language and one platform to manage policies across your entire organization or your cloud native stack, well, that looks like a big win. And here's the ecosystem that currently OPA integrates with. Now, there's logos of Kubernetes, Scalar, Claire, SysDig, ASP.NET Core, Spring, web frameworks such as Python, Flask, and so on. What this means is there's samples or constructs available for all of these different technologies as of today, so that OPA can be integrated into these systems as a policy as code technology. Now, if your application stack is not here, Well, it doesn't mean OPA cannot be integrated into that stack. Well, there's ways you can integrate pretty much any applications so that you can make policy decisions through code. And the other key important thing is OPA doesn't really care whether it's operating with Kubernetes or Python or SSH. In olden days, when we learned computer science in schools and colleges, we had these three basic things about computers. There's the input and the output. In the middle, we had CPU. Now, if you picture that and extrapolate that to Open Policy Agent, there's an input and there's an output. And in between, there lies the policy decision engine, that is OPA. OPA does not care what the service is, where the input is coming from. OPA does not care who's responding to the output as well. All it does is decides something based on a given policy. Now, that's all OPA requires. And when it doesn't care what the service is, how does all this work together? OPA doesn't care what your service is as long as the input is JSON. OPA works with JSON. That's the only one requirement. You need JSON, and OPA gives out JSON based on the policy that it has just evaluated. Now, with those two things in mind, what we're going to do now is explore the steps that it take to integrate OPA with your application and service. So the first thing that you need to do is create an input for OPA. When we say input, it has to be in a JSON format, so OPA can make decisions on that input. Number two, after you have that input, you have to give that input to OPA. In which way? We have to query OPA. And after you query OPA, OPA is going to respond with a JSON, and you're going to have to consume that JSON and enforce those decisions accordingly. Now, in this example, the decisions that we're playing with are a simple form of allow and deny. Now, OPA can be used in various other things as well. It can return an entire JSON payload as an output. And in this case, it just happens to return allow or deny. And again, I'll say this again. In this particular example, we're playing with this web application, and we're trying to see how policy as code could be integrated into the authorization module of the application, where the authorization is considered as policy here. Now, OPA can be used in other use cases as well. For example, if you have a service engineer who needs assignment to a particular person's personally identifiable information, only in the case where that service engineer is assigned to a ticket that is responsible for the person who raised that ticket. So if a person raised a ticket, the service engineer should only have access to that person's personally identifiable information. And that's a policy, and that can be something that can be achieved with OPA. And there's a lot of case studies out there on the internet, which is available in the reference materials as well, where you can go ahead and explore various other use cases of OPA. This demonstration and everything else that we're seeing today is intended to be very simple to facilitate an understanding of how all of these different nuts and bolts work together. So let's go. With that in mind, what I'm going to do is take you into this code that we saw, the application that we saw, front-end application and the back-end application that we saw, and how that back-end application actually implemented OPA by creating input and by querying OPA, and whether to decide to allow or deny a certain API call. So this is the code for the backend application, the backend APIs. And notice that when I say create input, that's the first box that was responsible for creating input. One line of code, split into 4 lines. And what we're doing there is getting the method, the request method from the HTTP stack, which is get or put, and the path, whether it is list cars or whether it is cars/car ID. And then we need 2 things to make this authorization decision. One is the access token to see whether the user MISBA belonged to a car admin role or a supervisor role or an every user role, which in this case happens to be the everyone user. And then fourth, we needed the ID token of the application so we can look into that ID token, extract that JWT, do verifications on top of it, and then explore the claims on that ID token to get the name of that user and to get the roles that the user belongs to. So those are the 4 things that were required in this case. And if we switch back to querying Open Policy Agent, so that's the second box. outlining how to query Open Policy Agent. OPA runs on the URL HTTP localhost 8000 in this case. So all we have to do is call that URL with our input. And then after we queried OPA, we have to process OPA's output. And that's the place where we're processing the output. Now, those are the basic three constructs that are needed. The code itself, the function module, if you notice, it's called def check authorization. And that method is annotated with app.beforeRequest. Well, in Python Flask, app.beforeRequest is a method that gets called before a request is actually processed. So this is a nice place to plug in our authorization controls. Let me exit out of Keynote, take you into a debugging session in Visual Studio Code, where the sample application that we saw in one of our staging environments, it's actually the same running in local here. Let me try invoking this. And when I try invoke, it's going to call the backend APIs that are written in Flask. And the backend APIs is what is tightly integrated with OPA. And we're going to see that in action. When I hit invoke, I'm going to be taken into the debugging session in Visual Studio Code. Now, notice that this is the same code that you saw on the Keynote slide. And because, let me switch back to the browser again. What we're trying to do here is we're trying to get a list of cars. That's all we're trying to do. And going back to Visual Studio Code, and if I continue this debugging session and explore what's inside the input, you're going to see that the method is options and the path is cars. Notice the method is options and there's no value for authorization. There's no value for the access token there. That's because before an actual method gets called in an AJAX fashion, because of same origin policy and cross-origin resource sharing, you have to get over the course options work first. So I'm going to skip that and then break again to a place where we're actually breaking into the actual request. Now, if you look at the input, there's the get method for cars, and there we have the access token, which is a bearer token extracted from the original method, and the ID token again extracted from the original method. And right after that, we're going to query OPA. So that request.post is actually what's going to query OPA. And OPA, after we're querying OPA, we're going to process that request as usual. And in this case, we're converting, because OPA gave back JSON, we're converting that JSON back into something that we can consume in this case, which is true or false. And again, we're logging that. And if the verb is not allowed, if this operation is not allowed, then we're simply going to abort that request. And notice that the input that we sent, which had 4 things, is also printed on the log console here. Let me copy this so we can use that later. And now if we continue this debugging session, go back to our browser, that request is allowed. Now, if we try to put cars with a car ID with some sample data, as long as it's JSON, it's all right. So if I copy this and paste that here, and because we did not change this policy, we only changed it in our lab environment in the beginning, because we didn't change this policy. If I step through this debugging session and verify whether that's a course request or not, okay, that's a course request, and let's allow that. I'll break back on the original request again. So there, we're trying to put cars with car and car ID with an access token and ID token. Is it going to be allowed? Well, by default, it's not allowed. So if we check the response, we get a false there. And hence, because it is false, we're going to abort that request with a 403. Go back to the browser, and request is forbidden. Now, in a neat way, without changing anything in our Python code, as we saw in the demonstration initially, we were able to modify policies and apply changes to an application dynamically without changing a single line of the application code, because the application is coupled with Open Policy Agent as a policy decision-making engine. The only thing that underwent change in this case is the API auth_z.rego policy. And that policy is something that I can show here in my Visual Studio there, API auth_z.policy. So that was the policy that was responsible for making the authorization decisions. And this is the policy that we modified to allow MISBA, the user that had an everyone rule, to be able to put cars. I have this policy already present here in the Rego Playground. What is Rego Playground? Rego Playground is a tool provided by the Open Policy Agent developers themselves to for you to troubleshoot, allow, edit, build, modify policies. Now, this is the policy that was in the file API auth_z.0. Now, if that looks a little bit daunting, this policy didn't look like this on the first attempt. On the first attempt, the policy looked like this. Well, I just picked a sample from all the examples that are available here. And I picked a specific one where I had to decode JOT tokens, because from Azure AD, the access token and the ID token that we're supposed to parse is the JOT format tokens. Now, this is the policy that I took as an example and started modifying this policy, which today has blown up to be a policy, a full-fledged policy that can work for this application. And notice that these are different variables by default. We're allowing it to false. And here we're allowing it to true. Now, I'm not going to go inside the syntax of what it takes to write an open policy agent in Rego, because there's a great course from the creators of Open Policy Agent themselves. It's a free course where you can also learn how to write policies in Open Policy Agent. But the tool itself, this is the input that we gave to the tool earlier. Remember, there were 4 things: the method, path, access token, and an ID token. So those are the 4 things given as an input. And when I hit evaluate, then then Open Playground is going to take this input, supply it to the policy that is presented on the Rego Playground, evaluate, and supply the results here. Now, if we check the value allow, that is false. In this case, it happens to be false. And then, as you can also see, because I wanted this policy to look a little bit modular, first, I'm extracting the value of the ID token claims.name and storing it into a variable user. And that's the variable that we're consuming here. So we have to request. The request is get, and if the path is parsed, and if there's any authenticated user. And how do we know if there's any authenticated user? Well, as long as there's an ID token claim with a value name, and that means there's an authenticated user. And that's the only thing that supplements that claim, saying, okay, we have an authenticated user. And when we have to check whether someone is a manager or not, then that goes a little bit deeper. And remember, the access token also has roles as a part of this claims. We're storing that into a variable. And if I scroll down all the way to the bottom, I have this little helper methods that say, if he's a car admin, hey, as long as the car admin is present on the list of rules that were returned as a part of this JOT token, then that person is a car admin. And I'm consuming that rule, consuming that variable inside this allowed rule here. That's one way to play with Rego policies. If I switch back to my keynote session, there's plenty other ways to play with open policies as well. We're done with that code demonstration there. Oh, again, the other important thing to remember is OPA is just responsible for making the policy decision. OPA doesn't care whether someone enforces or allows or denies a request. OPA just tells you whether something is allowed or not. OPA just told us whether something is allowed or not in our sample example. And then we had an if statement in our Python code to enforce and abort that policy when that request needed to be denied. So it's the responsible of a service in this case. The service was an API in our demo application. It can be Kubernetes, admission controller, or it can be your Istio service mesh, or it can be your ASP.NET Core application, or whatnot. So OPA just makes that policy decision, and it's the responsible of the backend service to enforce that policy decision. So writing policies in Rego, We just saw the last example there, play.openpolicyagent.org. There's also an add-on available for Visual Studio Code where you can write these policies and develop, debug, and check the code coverage of these policies in Visual Studio Code right itself. And it also has a REPL environment, just like we have in Python, Ruby, and other programming languages that can be integrated right into your terminal or Windows console. With that, there's also further reference materials. We have a curated list of custom policy as code projects. There's blogs, videos, tutorials, things that we use, things that we've collected. And here's that awesome free course from Open Policy Agent themselves on the Academy website. It's free. Check that out. It doesn't tell you everything that we've covered in the session today, but it's a great course to get started, to get a solid understanding of the Rego policy syntax and other things. Now is a great time to ask questions. I hope that session was a little bit informative to you, and I've stayed true to explaining the basic nuts and bolts of what it takes to integrate OPA as policy as code technology in your applications and your technology stack. I'm open for any questions that you might have right now.